Good morning. And today we're gonna talk about the basics na naman. And this is your introduction to vector analysis. So here's your course outline, or at least in subtopics under introduction on vector analysis. You probably studied this before, back in your high schools, your senior high school. Our goal is, for you to understand the following concepts like why dimensional homogeneity is important, and then the difference between vector and scalar quantities, what direction, um, and why why direction matters in vector quantities, and finally basic arithmetic equations to find the vector components and or the resultant. So with that, before that, we should get our bearings and ask ourselves, where are we in physics, and ask what is the definition of physics. Okay, quick Google search, in its basic sense, it's basically just the study natural or physical phenomena of the and the fundamental laws governing governing them. You can read through it. Survey would define as the fundamental physical science. It's a fundamental physical science concerned with understanding the fundamental principles of the universe. And the good thing about physics, like it's the foundation for other sciences. Like once you understood the principles or rules or the game of physics, you understood why they define chemistry that way, and then from chemistry you would understand rin yung biology, because they're kind of related. So you're going from the microscopic to macroscopic, and then it's kind of divided into 6 areas or 7 areas, depending on which book you're reading. Pero I'd stick with the 6, and it's divided into classical or modern. Classical, or the humble classical mechanics, classical physics, those developed before 19th century. Those before developed after was your modern physics, like quantum mechanics and relativity. We are not gonna discuss quantum and relativity. I'm sorry, Einstein. I'm not too smart for that. So we're here to discuss most of the time in engineering course, mechanics, thermodynamics, electromagnetism, and optics. So I believe ito yung ENG 207A nyo, and this is the ENG 207B. Just to give you a heads up, we're gonna talk more about the classical mechanics, and you guys will be talking thermodynamics more down the line in the next few terms. As you all know, classical mechanics spends most of the time on understanding moving objects that are large relative to atoms and that moves at speeds less than the speed of light, as Survey would define it. And relativity naman was the other part, because it's describing objects moving at any speed, even to the speed of light. Thermodynamics naman, which probably one of the favorite maths na meron ako dyan, in physics, the combination of math and physics, because you're here to understand the not just understand on paper, but you can actually visually see and understand how heat, temperature behave in a closed or open system. You see how it affects your hardware. You see how it moves from one point to another, even if that point is actually 200 meters above your sea level. So it's really cool. And then electromagnetism is about dealing with electricity, magnetism, fields, and the behavior of light. That is optics, the behavior of light and interaction with materials respective to it. Okay. Okay, so far this is something much more familiar pa. We always see this lessons pa naman, no? So let's start formally with dimensional homogeneity. I find it funny because back then this is kind of intuitive na. We know na we have to, we can only add two similar terms. They have the same quantity in the same unit. I'm pretty sure back then, if you want to repeat that experiment, you might as well have a standardized means of measuring things. You can't be using one's foot to measure and use your foot to measure your house. You gotta have a standardized. If it's 1 meter here, it's gotta be 1 meter there, dapat. Okay, and there's a cool history about how the English system came to be. They say na parang the foot is yung measurement ng paa talaga ng isang royalty doon. But yeah, as we all know, it really it's not really dependent. So the world, made new standard unit of measurement, or SI. And one of the the top three that we're gonna be using most of the time is length, mass, and time. And they have a standard unit measurement of meter, kilogram, and second. And the benefit ng metric system is that it's scalable, you know. For example, if you want to know how many meters are there in if you get to write down, 1,000 meters, sometimes, there's just three extra zeros. So you add prefixes like kilos or kilometers. So you know that it's 1,000 meters. So there's a corresponding prefix for it. And I'm sure there's a whole bunch of lesson behind it, and you've been taught about it before, and you can check it out in your respective reference books, or just Google it out. Okay. So for most of the time, we'll be dealing here, especially for one-dimensional and two-dimensional motions, land mass time lang tayo muna. Temperature, amount of substance, which is much more, microscopic, or your mole, and yung current ampere and luminous intensity candela will be to suggest some of the basic measurements that, representative ng classical mechanics that's being used all the time. Okay. Oh, check that out. Our first problem. So, how would you do this, ba? Like, for example, you have a problem, like you want to convert 14.7 pounds per square inch. Vector quantities are basically have both value, a numerical value or magnitude, so to speak, and a direction, like, velocity and displacement. And scalar quantities are completely, they just have value and they have no interest in terms of direction. Okay, so let's just take an example and try to, appreciate it better. Say you're doing some cardio, running some back and forth. I think we call that what, suicide drills. So you start with point A, the T0. Then you run all across the court or to point B. And in 1 minute, you reach that distance. I'll show you the distance later. And then you go back to C and then D. And this is your total distance traveled and the interval distance. The question now here is what is distance? What is the total distance? And what's the total displacement? Essentially, when you're talking about distance, you're talking about the total traverse length, essentially. So the guy, this particular person, traveled from point A to B. That's 4 plus 15 plus 4. And then he went back to C. So that's 4. So on top of that, you add another 4, you add another 15. And then from point C to D, you add another 15. And you will get 57 meters. Now, the next question is, what is the total displacement? So again, the distance is basically the total traverse length. You just add them up. Doesn't matter if you go, we're in physics, we have what we call reference point. It doesn't care whether it cross yung reference point. You just add it up. If you go back to the original position, you just simply add yung total traverse length in. But for displacement, or what we call here x, and normally distance we denote it as d. Pero I just got to write in distance because we use several variables as d. But for total displacement, we coin it as x or delta x. So what's the total displacement? Okay, 19 meters. Okay, so anyone can help me and Ruel explain why it's 19 meters? Can I call on you, Michael? Yeah, go ahead, speak up, man. So why is it 19? So for everyone to know. Assuming you don't know your formula. Okay, assuming you don't know your formula and you just have this particular, you just have some particular, thank you, Michael. So just in case, so what Michael did, wait lang, yeah, my tablet. Okay, there we go. Let me just write it here lang, Dito na diretso. Let's go with green na lang. So what Michael did, he knows yung total displacement. Basically, what we say total displacement is also translate to total change in position. Get it? Change in, kulang ng E. Change in position, or what we call delta x. Yeah, that's an ugly delta. Delta x. So what he did is all he did lang naman is to know lang naman yung final position niya and subtract it dun sa initial position. So XF, or yung final position mo is D. You just measure it from the point of origin, or yung tinatawag nating reference point. Wait lang. Most physics will use yung frame of reference, reference. There we go. So yeah, this is your, so meaning if at point C got passed done at bumalik siya sa point A, what's your displacement nun? From between point A to point C, if bumalik si point C to A, that will be 0, since you basically started on the origin, or your original frame of reference. Okay, so he just plugged it in. He just measured your distance from A to D, which is what, 19. Oh, sorry, yeah, 19 minus what, the initial position, 0. So that's it. Pero what if you don't know nga tong formula na to? So just looking at it graphically lang naman, or visually in this case, so just switch colors ng konti. Let's go for orange again. So just all you have to do lang naman. Okay, so this is my reference point. I just have to count. So from A to B, I know that's 19. Wait, sorry, 23, no? Yeah, 19 plus 4 is 23. But I went back to C, so this 23 will now move to, this will be 23 minus 4 minus 15. And then from here, whatever yung value ng combo that you gotta add plus 15 to get yung dito. So I think this is 4, and you 4 plus 15 is 19. So again, total distance is total length traversed. Total displacement is yung total change in position. So you're talking about change. Concept check or pop quiz. Which are the following are vector quantities, and ano dyan yung scalar? Let's call on, let me just switch tab lang naman ng konti. I just want to call a group naman ng konti. Yeah, let's call group 1. Any representative from you guys? So that will be Paulo, Nathan, Carlos, Arvin, and Jessa. So yeah, let's do this one by one. Is your age a vector or is it a scalar?
Sir, it's a scalar.
Who's talking?
Arben and Sheta po.
All right, Arvin. I really need an extra pen. Yeah, here we go. Arvin. So what? Your age is what? Scalar.
Scalar po, sir.
Yeah, because time is scalar. Doesn't really pertains to direction. Even if you have no, it's just magnitude lang talaga. Unless you're extra-dimensional being, so that you have a sense of when your when is now a direction. Pero we're not that. Okay, we're just talking planet Earth, good old humble planet Earth. Okay, next, Arvin. Is acceleration a vector or scalar?
Vector, sir.
Sorry? You can chat it up if you don't know.
Sir, vector po.
Vector daw. Okay, good. Actually, tama naman yun. It's vector. Why? Vector kasi it has a magnitude. Again, it has a magnitude and a direction. You cannot specify acceleration without pointing where it's going. Or what? Group 1.
Vector po.
All right, vector. Speed.
Scalar po.
Scalar. How about mass?
Scalar.
All right. Because it's pretty constant naman rin. Pero unless we're talking about weight, now it becomes a force. Now we have to specify direction, whether it be pulling down or pulling up, right, left. I'm pretty sure some of you have seen this before. Some of you have read it. Some of you loved it. Not sure who does love coordinate system. But yeah, it's kind of nerdy rin naman eh. So now we know yung value and direction. So what now? to make sense of the magnitude and direction of a vector in our world, we use systems like this, the Cartesian, the coordinate system. In this particular case, the XY graph, or the coordinate system. The x-axis, also known as what, abscissa, if I'm correct, and the y is the ordinate. But most of the times when you're viewing it in a radar or parang radially, we use most often yung polar coordinates, where we know lang yung x and y point, and we reference it from our axis, and in our case, north, south, east, west. Okay, and then what we do here is that for us to identify the kung gaano kabigat or kung gaano kabigat yung magnitude, we use yung Pythagorean, yung definitions as defined by Pythagorean theorem, like in distance formula, yung trigonometry nun, c squared equals a squared plus b squared, yung relationship behind it. So we use those principles here to identify yung resultant, or yung r, or yung, or in this case, we also know rin yung x components and yung y components ng some particular vector. Okay. Also, being mindful of where the reference point is. As you all know, from polar coordinates, from counterclockwise, it's gonna be a positive angle. If you're gonna be counterclockwise, it's gonna be, you have an idea. It's not exactly negative angle. You just know which part of the quadrant it is. Okay. The same way then when you have 2 points. So you have yung first, second, third, fourth quadrant. So a little review lang ng algebra. For first quadrant, the x and y axis, the x and y points are positive, while in the second quadrant, only the y-axis is positive. In the third quadrant, both y and x-axis are negative, and the fourth quadrant, positive yung x-axis, while negative naman yung y. This is it should be parang other professors or other instructors would not mention it before. Pero it's actually intuitive. It should be known and be intuitive in your head. Na if you see yung signs na to, you will have a clue na, okay, I know that this is gonna be a negative value. So kasi yung direction ng vector ko going towards here. Or positive to kasi it's supposed to be placed in this particular quadrant. Parang ganun. Okay? Time check. Oh, it's 8 o'clock. Right. So how do you, in physics problems, and how do we usually represent them? Vector quantities they're usually represented by a letter and with an arrow on top of it, just like so. Pero if not, most physics problems would just bold them. In books, they would just bold, type it up in bold letters, But in handwriting, it's kind of hard to do. Sayang sa ink. So I'll be interchangeably using yung bold pati yung arrow part, and it's usually written. So we have a sample here, and please note that we have a sample vector A and vector V, and especially if we're gonna do it graphically lang naman, it's represented that. So you can see yung magnitude by the length, yung body ng arrow, and yung direction at which it's going. So yun yung magnitude and direction at the same time. Hence vector A. Same with vector V, it could be slant rin naman. Okay, so if you get a plot yung points na yun, so vector A has points ng x-axis as 4 and y as 0, and yung B mo somewhere in between 5 and 6, and an x somewhere, it's 4. Okay, and also if you're gonna ask me, sir, can I start by yung does it need to be starting at the origin? No, the vector need not to start at the origin. Okay, it could be here, it could be here, and it could start here and here. Yeah. As you can see, I didn't use yung arrow. So I just assume it's bold letters. Okay, maliban sa XY axis, like I mentioned earlier, I think the nabanggit ko is yung, when you're hiking, you want to know which direction you are, and sailing through the seas. So we normally using north, south, east, west to get a sense where we are, even though our Earth, this oblate sphere of it is it's really a sphere, oblate spheroid. And pero it just makes sense on a grid system, on where you are. So you know your bearing, so to speak. Yeah, so vectors exist in between two axes, naman, just like northwest or southeast, and then may have the same or different sign or conventions for the x and y axis. So as you can see here, plus plus, y, depending on which quadrant. Now, if you're given a magnitude, if you're given a vector, and the magnitude and a direction na parang northwest lang or northeast lang, meaning these are exactly 45 degrees with either x or y axis, or yeah, with either references axis. Okay, and for example here, southeast direction are positive in x but negative in y. It really depends on which reference point you're using, really. So as mentioned before, vectors need to start well, they don't need to start an origin point, but you can draw it up individual vectors, and with polar coordinates, this exists between axes and will vary in sign depending which quadrant they fall in. Now the next question, what if they're not exactly 45 degrees? We have what we call, complementary angles. So what if like this, 25 degrees? And the convention here is, it's pointing eastward, and you have to mention, okay, so which axis is the angle referencing from? So it's pointing east and 25 degrees east of what axis? South. Or in this case, you can also call it 65 degrees south of east. As long as you know where it referencing from and using proper signs naman, ay, di pala magandang dilaw. So this one, 65. And since they're the complementary, just minus it by, you just minus 25, 90 with 25 degrees. I think I have a snippet yata dito, pero this will be good idea na if you could still recall na if I put through this arrow on the other side of the axis, what will be my angle here? Consider it as a pop quiz. You can type it in. Correct. I forgot yung postulate behind it. Pero if you know yung transversal theorems nyo and postulates and yung congruent angles, that will be very helpful in the coming problems. Rin. Okay, next. Okay, so yeah, pop quiz. I want to know, I am gonna call a group na lang. Let's go with, mas malapit na yung birthday ko. I'll go with 6. Group 6. So, sige, anyone from you? Nakita ko si Mr. Ernest dito. Dito ko pala, Ernest. All right, so determine the direction of the vectors drawn below. Anyone want to have a go? So, sige. Let's start with vector A. It's actually quite simple lang naman, ano? Ernest, maybe you can help me, man. A. So A has a particular magnitude, and what is the direction dito? How would I describe it?
Going southeast.
Correct, kasi 45 degrees naman siya, so either way it's good, no? Southeast.
Sir,
Okay. Yeah, go.
for A po ba, I can also describe it as east of south,
Technically, you can. Based on
45
the
degrees too.
So, pero it's kind of odd, no? If you think about it. Forget the exact rule dun eh. Pero
Yes, sir.
people stick with southeast kasi with that convention, northeast, southeast, northwest, kasi na either axis is 45 degrees eh. So you stick with the original one, Okay?
Okay, sir.
Okay, good question. So with B, to you asked the main question, how could we specify yung direction ng B? So we see here, moving counterclockwise from the x-axis, 120 degrees. Pag ganun siya, no? Medyo pangit.
30 degrees, sir.
Nice. Why?
30 degrees north of east. Is that correct? Or east of north?
Try again. See, you got it right, the latter part. Tama ka dun. The only reason why we do that because we cannot really reference B from because it's protruding both yung X and Y axis. Eh. So we gotta reference, at least one the nearest axis that is here. So what you did was, you just
Okay, okay. Gets ko, sir.
dude, you got it right. But why are you surprised? So yeah, tama naman doon. So basically 120 minus 90 lang naman yun, and then that's 30 degrees. You mentioned 30 degrees, so you're basically referencing it's going oh shit, wait lang. Yeah, there we go. 30 degrees is basically east of north.
East of north.
See, because you're referencing it from the north axis or the y axis.
The y axis. Yes, sir.
If you're gonna call it north of east naman, what's the angle?
60.
Yes.
Okay, sir.
So, ganun lang. Dahan-dahan sa space bar. With C, so we have here west, we have here south. Anyone from group 6? Kindly help me, Carlos. So, ano ang magiging direction ng vector C? So, we have here yung certain magnitude C. We know yung 15 degrees, pero where? How would I, coin it? Carlos? Do you see the pattern, class? For those who haven't encountered this before, this will be very useful. If ever man ma-take away, hindi nyo mag-gets lahat and wala kayo sa, sa bundok or hike kayo and ito yung naalala nyo. Among other things, you guys will be fine. And along with the other facts, follow the river, stay with the river's path, making sure you're hydrated and all. You'll survive if nawala kayo. But at least here, you'll get to know your bearings. Clear pa naman, sir. Okay, there we go. Sige. Before I move forward, wait lang, let me check my código. We're gonna go with basic rules ng vector arithmetic. So we've done with the basics, 1, 2, 3. We know now, we go with the definition of vectors and wait, my cat is trying to get in. No, you're not gonna get in. Vectors and scalars, and we know why dimensions matters, especially sa mga equations na to. And did a little bit of definition ng gagawin natin sa mechanics. So, do we have any more questions dito? Just give me a thumbs up for no questions na. Yeah, there we go. Okay, I'm glad you guys are still here. Let me just check yung count. The count is still 42. Oh, so present lahat. Nice. And I appreciate you guys coming in. I know it's an early class talaga. Trust me, stick with it. Just, show up. And matatapos natin to physics and, para matapos na kagad to. And the next term kagad, And sooner or later, it's Easter break na. Whew. Okay, next question. Sige, ang next topic natin, again, yung rules ng vector arithmetic. So as you know, we can add, subtract, even multiply or divide yung mga vectors. The multiplication part and quite frankly, yung multiplication and yung division part does make sense when you're, on other advanced mathematics. Kasi you're trying to expand yung space or trying to diminish or divide yung space. More commonly, we're going to use yung addition and subtraction here. But I'm still going to show you some rules ng multiplication because the rules of multiplication is practically similar to division. If you're, in the future, you're really doing heavy math, particular to space, in trying to understand whether subatomic yun or microscopic, or in our case, macroscopic like the size ng solar system natin. That matters. Yung if you want to know how fast are we expanding, or what's the rate of expansion ng atoms, so to speak. Yeah, that matters. Pero for the basic equations that gotta be useful for us, addition and subtraction will suffice. Okay, so here are the basic rules lang naman. Two vectors are considered equal only if they have equal magnitude, so same yung haba, and they point in exactly the same direction. So in this case, they're parallel, most of the time, as represented like so. And number two, the sum of two or more vectors is represented by a resultant R. So we have you vector A here and vector B. The resultant is the represented by the resultant R. And if you notice, he connects yung R mo from the tip ni A to the from the tail ni A to the tip ni B, which most physics books will call the tip to tail method. So you can still add more vectors then at the end of the day, but what matters is your last arrow and yung original tail. So like ABC, still get that. So remember this equation. So resultant is just the summation of two or more vectors lang naman. Okay. Next. Again. So here's the basic. Ito yung scalar multiplication. So, medyo bibilisan ako ng konti kasi it's 8:20 na pala. We're gonna be solving a much more problems by later. So here's like a scalar. For example, A is multiplied by a positive scalar quantity. What is going on? So vectors follow commutative law of addition, meaning vector A and B, the sum of the vectors A and B is also equal to sum of the vectors B and A. Okay. So ito yung, I think other books would call it like geometric addition. They have other names, pero it's basically commutative law lang naman. The other one is that they also follow, if they follow yung commutative law of addition, they also follow yung associated law of addition. Like the sums of A, B plus C is also A plus B if C. Yeah. So mapapansin nyo yung resultant is pretty much the same visually. And then the negative of a vector has the same magnitude, but it's just, turning in the opposite direction lang naman. And the vector subtraction is performed by adding the negative of the vector being subtracted from another vector. It's kind of counterintuitive that you're going to add the negative, pero this is going to be crucial when you're trying to visualize it. So you stick with your addition, and you know that the negative sign doesn't really pertain lang naman sa value. It just pertains to the opposite direction at which it's traveling, or it's pointed at. Okay. So in this case, like A vector A minus, I think nahaharang yung the tail yata dito is here. Yeah, dito yung arrowhead niya ng B, and this is A. So A minus A plus minus the opposite vector B. Ito is R. All right. And often the problem will give you this lang. They will give you the B vector. So the vector, and when you have an equation problem na ganito, you have to identify iba yung direction nito. So the angle theta here, see, is naka-base sa east of north. And here naman naka-base siya sa south of west. Same magnitude, different direction lang naman, like the rules would dictate. Yeah, we don't really use that, so we gotta skip that. Okay. So when it comes to vector arithmetic, it's important to know that each vector, if you're gonna do it mathematically naman, we have the x components and the y components din naman eh. So if you're gonna do it graphically or mathematically, you would plot it out. Yung resultant ng A, this one has its A, x, or your x components ng A, and the y components. And as you can see, it does form a triangle, for a single vector, So it's pretty much easy to, associate or use yung definitions ng normally at an angle, pag polar coordinates, okay? And it's easy to use yung principles ng Pythagorean theorem and yung mga trigonometric properties natin dito to define yung vectors, yung vector components ng AX and AY. You see cosine, soka, to, okay? So as you can see here, AY here is just simply signed. So sine is A sine theta lang naman. AY nyo, yeah. Opposite over adjacent hypotenuse, so to speak. Yeah. Quite frankly, hindi ko kinabisado yung Sokoto. I just know na from here, I know lang na just from the triangle itself, I know na what the AY is and what the AX are. AX is simply yung A cosine theta lang naman yun. AY is simply yung A sine theta. Okay? So what if you have more than, you can also use this to get yung A. Once you get your AX and AY values, you can also get your theta by simply doing the inverse tangent. So again, what if you have multiple vectors, more than two, like A, B, C, and more? So if you remember this, the resultant is simply the summation of all the vectors available. And same also with the components. The components for in this case, the horizontal components ng R is the summation of all the horizontal components ng vectors A, B, and C. Likewise with the vertical components. Ry is just the summation of vertical components or y components of A, B, and AY, BY, and CY. And you can also use your principles to great old R squared ng Rx squared plus Rx squared. And also this. Okay. Concept check. It's just, some of the test questions sometimes ganito. Choose the correct response to make the sentence true. A component of a vector, well, if you have your lecture book, you'd know your answer. Ay, sa lecture book. Why wala pala siya. So, a component of a vector is blank, larger than the magnitude of the vector. You can just type in your answer nyo dyan. Is it A always, B never, or C sometimes? Okay, we got C, B, 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 B. Okay, the correct answer is actually B. So again, a component of a vector, which means, wait lang, saan ba yung, so let's just say this. A, we know meron siyang AY, AX. So it holds true na the components, whether X or Y, is never going to be larger than the magnitude of the main vector, no? Okay? I know it's kind of confusing. Sometimes tinatalo tayo ng English. Okay lang yan. I'll try to avoid questions na ganito during exam. Just go straight with some math problems na lang. That's why we're here. Okay, next concept. So another chance. The magnitudes of two vectors A and B are 12 and 8 respectively. Now, which pair of numbers represents the largest and the smallest possible values of the magnitude of the resultant are A plus B? You can type in your answer. Is it A, 14.4 and 4, B, 12 and 8, C, 20 and 4, or D, none of these answers? I'm gonna give you a clue, it's not D, okay? May sagot yan. So the first one who got it right is Ruel. Yeah, it's actually C. So the largest is what? 12 plus 8 lang naman, diba? So that's 20. But if you add a negative vector doon, or parang the opposite of a vector on either side, the smallest one will be 4. Okay, next. Thank you. You know what? Actually, just in time, Ilagay ko pala to, Okay, last. one last pop quiz. If vector B is added to vector A, which two of the following choices must be true for the resultant vector to be equal to 0? Would it be, yeah, which of the two following choices? Two choices. So I only see B. So okay, pag select natin yung B, A and B are parallel and in opposite direction. That's correct. What's the other one? A and B have the same magnitude. All right, sige, let's do this. So like I said, you can solve a vector either graphically, literal pen and paper and ruler and protractor, or yeah, the tail to tip method. Here are the steps to do that. Essentially, you just draw the first vector with its tail at the origin, starting point. You place the tail of the succeeding vectors to the tip. So you pagsusunod-sunodin mo. So A, B, C. So A, then B, then C. And then the order of placement of vectors doesn't really exactly matter. And then once all the vectors have been drawn out, draw the resultant vector from the tail of the first vector. And then to the tip of the last vector drawn, just like so. Parang ganyan. You know, the importance lang naman ng graphical solution is to, you know, help you visualize where your vectors are, what and where possibly your resultant could be. And believe it or not, in a board exam, it's kind of like a last resort thing. Kasi especially kung naka-scale naman yung naka-scale yung graph and yung lines. So you can actually, you know, use your actual ruler and protractor during the board exam. It's kind of like a last ditch effort, you know. If you forgot, if nagpapanic ka na and it happens. So you just measure it and your brain simply kind of processing computation. So you just measure it na lang and just find. It's a good thing na multiple choice in board exam. So you just, you know, circle the one you got close answer with it. And the preferred method, which if you know, really want, if the problem requires an exact, or if the task requires an exact coordinates, so you use your mathematical solution naman. So you make use of yung Pythagorean theorem, yung definitions ng ng Pythagorean principles, trigonometry here, knowing yung components niya, yung relationship between yung trigonometric properties like sine, cosine, and tangent. Okay?